Hi, welcome to this podcast, which is for the OCR Computing A Level, Unit F451. And this podcast is based on knowledge-based systems, or what is sometimes known as an expert system. Right, so what is it? What is a knowledge-based system? Well, this is a system that uses knowledge of a specific topic from experts to apply a set of rules using an algorithm to give information to people through a user interface. Okay, it can be queried on all the information it contains to present back an idea on a specific topic. So what we're going to do now is look at what a knowledge-based system is in a bit more detail and look at what that first bullet point means, each of those different things in that first bullet point. Generally, if you answer your exam question in what a knowledge-based system is, on the top point there, that would give you the marks if you just had a simple question of what is a knowledge-based system. You have to be careful though, because sometimes your question might say something like, how is a knowledge-based system set up? And that's when you might have to think about it a little bit more and maybe word it in a different way. Also be careful to see how many marks are being offered, because you might need more detail than that is there if you've getting any more than 4 marks. Okay, so let's have a quick look. If you go on rightdiagnosis.com, the symptom center, you can have a little look at what is something that looks like a knowledge-based system. So what we have here is where I'd go on and I'd select from common symptoms. So on here there's a load of common symptoms and I'd choose one that I think applies to me. So what I might do is choose runny nose. So I've got runny nose. This now tells me there's 726 causes of runny nose. Now, is there actually 726 causes? Well, there's 726 causes in this system. You'd hope that the system would have every single cause of a runny nose, but you never know. So that's something you might want to think about. So say there's this 726 causes of runny nose. Then got a choice with what I do. Do I just leave it at that, or do I narrow it down? Well, I'm going to query again and narrow it down. So I want to see what else I can find. So I look at the other symptoms that are there. So I've got a load there. There's more than that, obviously. But head symptoms, face symptoms, respiratory symptoms, nose symptoms, nasal congestion, and so on and so on and so on and so on. So I'm going to choose one, and the one I'm choosing is cold-like symptoms. So cold-like symptoms, which is here, tells me now I've got 689 causes. So if I go to it, cold-like symptoms and runny nose, 689 causes. So that narrows it down again. So I'm now narrowing down the options of what I think I've got. And I'd keep going all the way down until I think I've got to a stage where I can see actually what I have. And what I might find if I keep going and add a few more things is that I've actually got the common cold. So that is an example of a knowledge-based system or expert system. But this is something I want you to think about, because you might get a question slightly different to what you've looked at. It might be tied in a little bit with the last topic of the unit, which is the implications of computer systems. Right? Could you replace a GP doctor with a knowledge-based system? Have a little think about that for now. Is it better to go to see a person? Alright, is it better to go and see a person? Let's have a think about it. Well, the knowledge-based system will follow the same rules each time. Therefore, it should come out with the same answer each time. Alright? Looking at the example before, what if you started complaining of a rash along with other symptoms such as stiff neck, light aversion, and so on? You might find that you diagnose yourself with meningitis, mainly because of well, those symptoms, stiff neck, light aversion, rash, along with possibly runny nose, could be the symptoms of meningitis. Alright? However, what if the rash was eczema, but you didn't realise? It's likely that you've got the flu and you have the touch of eczema at the same time. Now, a doctor would be able to look at the rash and straight away say, no, that rash isn't meningitis, that rash is eczema. However, you aren't able to make that decision because the expert system cannot tell you whether your rash is eczema or whether it is meningitis rash. Now, you can make the system better, you could put pictures on, but again, the system doesn't have any intuition. They can't make a judgment. So, you know, there could be other things that happen. It might be that you've got a stiff neck because you've slept funny all night. It might be because you've got light aversion because you are fair-skinned and you're sensitive to light anyway. That, you know, all these different things that the system can't make intuition on, but the doctor can. So, do we replace these systems? Do we replace doctors with these systems? Well, I would suggest that it's not a good idea, but they are useful. If you're going to do it in certain cases, they are useful to get an idea of what the situation is, but you definitely shouldn't be replacing certain things with these types of systems. However, there might be other areas that could use a knowledge-based system and totally replace humans in that situation. So you really do need to be careful on any question on that. Read the question carefully and think about all the different reasons why and why not. Okay, for and against. Right, so let's have a quick look at the different aspects. Well, first of all, we've got the knowledge base. So these will be, if you've got 4 marks in a question, you're going to have the knowledge base, the rule base, the inference engine, and the human-computer interface are the 4 areas of a knowledge-based system. And these are the 4 marks that you will get if you just get a simple question of what is a knowledge-based system, a description using those 4 points. So, the first bit, the knowledge base. This is where the expert supplies system with information when it is set up. Many experts will have been interviewed and information collected to make up the knowledge base. Therefore, the knowledge base is all the information about the particular topic / area it deals with. So the knowledge base is all the information that is provided by the experts. Quite simple. The next one is the rule base. For us to be able to do anything with that knowledge, we need to have a set of rules. Okay, so the system needs to follow rules to access the knowledge correctly. If rules aren't followed, then the incorrect result might be displayed. All the knowledge-based systems will have rules that can be applied to the knowledge base, so i.e. the data within the system. So rules will be applied to the data that is in the system. As we saw before, when we do the questions, rules are applied and then it narrows it down. Okay, but we cannot apply rules unless we have an algorithm. So algorithms are set up to apply the rules that are in the rule base to the knowledge that is in the knowledge base. Okay, these algorithms are stored in what's called the Inference Engine. Now this is the difficult one, is remembering this, Inference Engine. Generally people get stuck on this point. Now Inference Engine, it's actually quite easy to remember this if we look at the actual definition of what inference is. Inference is logic. If we look at point 3 there, the act or process of inferring something that is inferred, or point 3 is logic, and then we've got various descriptions there of how it's logic. But essentially what you can think of is inference is logic. I've taken this off the dictionary.com, and logic is performed using algorithms. So if we can think, we need algorithms within our computer system to apply the rules. So if we've got algorithms is logic, which is inference. If you remember that inference is another word for logic, then we can have the inference engine. That might be one way you can remember it if you understand that. There might be other ways you can remember it. Have a little think if you can as to how. Last one, human-computer interface. So there has to be a user interface for the system. Can you use a system without user interface? Well, how would the user get the information they need if you didn't have a user interface? So this one should be obvious. Usually this type of user interface would have a series of questions that the user would go through, as we've just seen. Each time one is asked or answered, the amount of information returned would be narrowed down. So if it was an expert system on health, then the number of types of disease illness presented from the knowledge base would be narrowed down, as we've just seen. Each time a question is answered, the inference engine will apply the rules from the knowledge base on the answer to narrow down the set of information presented back through the user interface. Okay, so essentially that again runs through a little bit of how the knowledge system works. So let's just scroll out on this one so we can have a look at that all together. What we have then is a knowledge-based system has a knowledge base, a rule base, an inference engine, and a human-computer interface. Those are the 4 points you need to remember, and there's various ways that you could get asked questions on this. You might get asked questions on the implications of ICT, which we discussed a moment ago. You might get asked what is a knowledge-based system made up of, and those 4 points there, you might actually get asked in specifically about one of those 4 things. Or you might get asked how a knowledge base system is set up. There's various ways the question could be asked, but those are the things you need to know from knowledge base. Hopefully that's helped, and good luck with any such question in the exam. Thank you.